So we're going to have a look at how we can change the log of a particular base into the log of another base using one of the rules that's in our maths formula book. So we have this rule that says the log of x to the base b is equal to the log of x to the base a over the log of b to the base a. And we'll see how it works with an example, and then we'll apply it to this question here. So for example, if I had the log of 81 to a base 9, and I just picked this one because I think it's handy to do it in our head. The log of 81 to the base 9, well, 9 squared is 81, 9 to the power of 2 is 81, so the power is 2. We can change that into, let's say, log of base 3 by saying the log of 3 over the log of 3. We put 81, the argument of our initial log, as the argument of the top log, and we put 9, the base of our initial log, as the argument of the bottom log. And just to check that we do get 2 as an overall answer, that the equation remains true, well, 3 to the power of 4 is 81, so log 81 to the base 3 is 4, and 3 to the power of 2 is 9, so that's on the bottom, and 4 over 2 is 2. So we can see that it's true, and we can see that this rule works. Let's apply it to the one that we have. We have the log of 4 to the base 3, and what they want us to do is to change it into a log of base 2. So we're going to put a log of 2 on the top and log base 2 on the bottom. The 4, the argument of the log that we have initially, becomes the argument of our top log, and 3, the base of our initial log, becomes the argument of our bottom log. And so in this question we're asked to change from log of base 3 to this fraction which had log of base 2, and we can see that the a value is 4, so a equals 4, and the b value is 3. Now in this question we're going to carry this result forward, so we're going to use the result of part 1 in part 2, and then we're going to learn something in part 2 that can help us solve the very tricky part 3 part. So let's clear the screen and we will move forward. So just to see what we did again, we had the log 4 to the base 3, and we said that that was equal to log of 4 to the base 2 over log 3 to the base 2, and we're going to bring that solution with us into the next part. So here we have the product of two terms and they're equal to 2, so let us write it like this. So change our pen. So we have log of 3 base 2, and we're going to multiply that by the log of 4 to base 3. I'm going to show that it's 2. Now, we don't want to use our calculator for this. This set up in part 1 that we can change logs from one base to another, and we might see what happens when we go and do that. So in part 1, we identified that this here, log of 4 to the base 3, is log of 4 to the base 2 over log 3 to the base 2. So I'm just going to replace that. I have my log 3 to the base 2 here, and that's equal to 2. And what we should be able to see here is that on the left hand side we have a product here, two things multiplied by each other. If we divide above and below by log 3 to the base 2, we can see that we're left with log 4 to the base 2 is equal to 2, and that's a true statement. Log 4 to the base 2 is the number 2, as 2 squared is 4, so 2 equals 2 as required. So we've shown that the product of those two terms is equal to 2. Now this idea in this question carries through to part 3 when we have this situation replicated multiple times, and we can divide above and below by lots of common terms and cancel them in a way. So let's have a look at how we go and do that. So I'm going to write out this equation that I have, but I'm just going to add in a couple of extra terms just to emphasize the point, or just to show more clearly what's happening. So we have log 3 base 2, and that's multiplied by log 4 base 3, which is multiplied by log 5 base 4. And that would be multiplied by, we can see that the argument increases by 1 and the base increases by 1, and maybe we'll just do one more again just for emphasis. So that's going to be log 7 base 6, and so on until we get to the last two terms, and that would be the log of n to the base of the number before it, which is n minus 1, and then the next term would be log of n plus 1, and again to the base of the number before that, which is n. So I've added in these two extra terms just for emphasis, and we can see that in the question that's equal to 11. So if we replicate what we did in the previous part, in part 2, well, log 3 base 2, and we had multiplied that in the previous part by log 4 base 3, but we had changed that log 4 base 3 into a base 2 by saying log 4 base 2 over log 3 base 2. I'm going to repeat that process with log 5 to the base 4. That would be to base 2, that would be log 5 base 2 over log 4 base 2. And again, the next term would be make them into log 2's, and that would be log 6 base 2 over log 5 base 2. And again, one more. So we have log 7 base 2 over log 6 base 2. Now, if we were to come down further, we have the log of n to base 2 over the log of n minus 1 to base 2. And then finally, if we were to multiply that by the last term, which we can apply the same condition, which is changing it into a base 2, so log 2 over log 2, we have an n plus 1 on the top and an n on the bottom, and that's equal to 11. And look, something like this looks very tricky until we can probably spot the pattern. So what I'm going to do is I'm going to divide above and below by log 3 to the base 2, by log 4 to the base 2, by log 5 to the base 2, and so on. So I added in a couple of extra ones here. This log 7 to the base 2, if I divide it above and below, it would cancel with a term that was there. And similarly, we can see that this log n to the base 2, that would cancel with this log n to the base 2. And there would have been a term prior to this second last term that would have cancelled. We would have had a log n minus 1 to the base 2 up here, and it would have cancelled with that one there. So the only term left on the left hand side after dividing above and below by all the common terms would be the log of n plus 1 to the base 2, and that's equal to 11. So looks quite tricky at the start, but we end up with this very simple equation that is in what we call logs form. So to change that into index form, we do the following. So the 2, the base of the log becomes the base of a power, 11 becomes the exponent, and that's equal to n plus 1. Obviously we could have written that as n plus 1 equals 2 to the power of 11, and then n is equal to 2 to the power of 11. Let's subtract 1 from both sides, so minus 1, which is 2048 minus 1, so n is equal to 2047.